Okay, so now we would like to be able to solve quadratic equations using the square root property and completing the square. Square root property tells us that when x squared is equal to p, then x is equal to square root of p, or x is equal to the negative square root of p. A basic example for that might be x squared is equal to 25. Okay? I can take the square root of both sides, and that would be x equal to plus or minus 5. Now, keep in mind, I could always have subtracted the 25 and then took the difference of two squares. Okay. Even with the difference of squares, we are still getting two different solutions for this. Okay. So again, this will only work if the exponential power is a 2. Not cubed, not to the fourth, only squared. Okay, so let's take a look at two examples of solving by the square root property. Again, keep in mind you want the squared part by itself. So what? Subtract 48 and then divide by 3. Now that you have x squared by itself, I can now take the square root of both sides. Now, from here then, you know you have a negative under the square root, so that's going to be in terms of I, and the square root of 16 is 4. So my two solutions are going to be 4i and negative 4i. Okay, for the other example, again, I want to add 6 to both sides. Now, take the square root of both sides. Remember, plus or minus. So the square root of 24, I can simplify. I'll do that now. That's 4 times 6, and that breaks down as 2 times 2. 6 breaks down as 2 times 3. So the square root of 24 is the same thing as the square root of 2 times 2 times 2 times 3. Now remember, the index is 2, so I need 2 of the same factors to get 1 outside of the radical. So I can only do that with the 2. I multiply what's left. That's 2 times, that's 6. So here the square root of 24 is the same as 2 times the square root of 6. So we'll write that. So then we will add 5. Again, I will always like the plus or minus in between the terms, but you certainly can write it as plus or minus 2 times the square root of 6 plus 5. And divide by 2. So my two solutions then are written out here. Okay, the other topic I would like to discuss in the videos is what is called completing the square. Okay. Now, we're assuming we have a quadratic equation, ax squared plus bx plus c is equal to 0. To solve equations by completing the square, divide both sides by a to make the leading coefficient 1. Have it in the form of x squared plus bx plus blank plus c equal to 0. And in other words, I'm going to have the constant on the outside of the parentheses here. So if you recall, to complete the square, we take half of the linear term, which is b, not bx, but b. And then whatever you get from that answer, we're going to square it. Whatever is added inside the parentheses should be subtracted outside the parentheses on the same side of the equation. Factor the trinomial to a perfect square trinomial, and use the square root property to solve the equation. Okay. So now let us use completing the square to solve. Now, if you notice, 1, it's set equal to 0 already. That's good for us. And if you also notice the leading coefficient is a 1, we can immediately go to completing the square. So let's write it as this. So completing the square, half of 8 is 4. And 4 squared is 16. Add 16, but then I'm going to subtract 16. Now remember, because I'm adding and subtracting 16 to both sides, that should balance my equation. So now the trinomial x squared plus 8x plus 16, that is factorable. That factors of 16 that add up to be 8 are 4 and 4. 4 times 4 is 16, and 4 plus 4 is 8. So rewrite. Negative 10 minus 16 is negative 26. The rest of this problem now, I can use a square root property to solve. So add 26. Take the square root. Now, you want to take a look and see if there's any perfect roots I can pull out of 26 other than 1. In this case, there is not. So then from there, subtract the 4. So my two solutions then is negative 4 plus the square root of 26 and negative 4 minus the square root of 26. Okay, so let's take a look at the next example. We now have 2x squared equal to 4x minus 3. First of all, I'm going to set this quadratic equation equal to 0. So I'm going to subtract 4x. I'm going to add 3 to both sides. Now, notice the leading coefficient is not 1, it's a 2. So I'm going to divide every single term on both sides of the equation by 2. And keep in mind, 0 divided by 2 is 0. So now I want to set this up so I can now complete the square. So in order for me to complete the square, I'm going to take half of negative 2, which is negative 1, and square it, which is 1. So I'm going to add 1 and subtract 1 here. Now again, that trinomial is a perfect square trinomial. That can be factored as x minus 1 times x minus 1, which is x minus 1 squared. So I'll write it here. And 3 halves minus 1 is a positive a half. So again, the rest of this problem is nothing more than using the square root property. So subtract a half. And now I would like to be able to take the square root of both sides. Okay. Now, I am going to simplify the square root of negative a half. Okay. I'm going to do that above. So the square root of negative a half is the same thing as the square root of negative 1 over the square root of 2. So we know the square root of negative 1 is I. I want to rationalize the denominator, which means I'm going to multiply the top and the bottom by the square root of 2. So that gives me I times the square root of 2 over 2. Or if you would like to put the square root of 2 divided by 2 times I, that those two mean exactly the same thing. Okay. All right, so let's rewrite. I will use the second option, then add 1 to both sides. Okay, don't forget my plus minus, plus minus. Okay. Okay, now my solutions for this then would be these. Okay. Again, let me stress to you, when you have to use square root property, you do need to have plus or minus for your answer, okay, when you take the square root of both sides. Okay, last example I want to take a look at. Now this problem, it's already set equal to 0. That's good for us. But again, notice the leading coefficient is not a 1. So I notice here the leading coefficient is a 3. So I'm going to divide every single term by 3. Okay. So that gives me this. Now I'm going to set this up so that I can complete the square. Okay. So I will complete the square on the side here. So what? Half of negative 5/3. It's negative 5/6. And then I can square this. Keep in mind, a negative squared is a positive. 5 squared is 25. And 6 squared is 36. So I'll put 25 over 36 minus 25 over 36. Now, this again is a perfect square trinomial, but it may not be obvious on how you can factor this. So now what I'm going to do is I'm going to scroll up and look at the 2 previous examples so we can identify a pattern on how I could write this out. Okay, so let me scroll up. The first example, notice the first step in completing the square was 4. Notice when I factored it was x plus 4 squared. Positive 4 for the first step of completing the square. Let's go down to the second problem. Notice the first step in completing the square was negative 1. And notice when I factored it was x minus 1 squared. That is not a coincidence. If you complete the square correctly, you should be able to factor that trinomial using the first step of completing the square, assuming you've done it correctly. So we're going to use the very first step. In this case, it's negative 5/6. So I'm going to write this as x minus 5/6 squared. Negative 3 minus 25 over 36. Now you can verify this with a calculator, but that is minus 133 over 36 is equal to 0. Now, the rest of this you use the square root property for. Take the square root of both sides. Don't forget, it's plus or minus. Now, the previous problem, we had to rationalize the denominator. That is not going to be the case in this case because of the fact the square root of 36 is 6. That's already a perfect square. You would want to check to see if there's any perfect roots in 133 other than 1. In this particular case, there isn't. Add 5/6 to both sides. Now, I will rewrite this as 1 fraction. Okay. And then I will rewrite this as 2 separate solutions. So in case they ever ask for what the solution set would be, this is exactly how you would write it. And this is concluding on how to complete the square and using the square root property.